So I ran out of space on that last video, but I was just saying, finding these heights for my different rectangles and remembering that it was 0, then 7, then 12, then 15, then 16. And I'm getting these heights by basically plugging in the x values into my function, right? So plugging in -4, -3, -2, -1, 0, 1, 2, 3. And I ended up with an approximation there using a left endpoint approximation with 8 subintervals of 84. So last one here is saying to do a left endpoint approximation with 16 subintervals. So now I've got basically 1 every half. So it should be there, 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 here, there, 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 and there. I'm using the left endpoint, so this one, that one, that one, that one. There, 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 there. This is over, 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 over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 little rectangles. They've got a width of 1/2. And basically what I would be multiplying by is 0. Then I'd be adding plus f of -3.5 plus f of -3 plus f of -2.5 plus f of -2 plus f of -1.5, realizing now that this should be g because I called it g of x, but whatever, plus f of -1 plus f of -0.5 plus f of 0 plus f of 0.5 plus f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and that's it. I don't use the last one, right? I don't use f of 4 because that would be one of the right hands, and I'm using the left hand. So I'm not going to compute that right now, but we could, right? We would plug all those points into the functions. The integers are easy to do. The other ones are a little bit annoying. Clearly, this would give me, maybe not clearly, but probably, this is going to give me a better approximation because I've got smaller rectangles. But it's a real pain, and it's not that good of an approximation, probably. So we don't really want to do this in the long term, just like we don't want to do, you know, the limit as h approaches 0 of f of x plus h minus f of x divided by h every time. No, no, no. We just want rules. So eventually, we want to find some rules. To find this area again on the calculator, you can graph the function. It was -x squared plus 16. Graph it's going to look like this. Change my window slightly to go from -5 to 5 and say -1 to 18. So that gives me a nice picture of my graph. Then to go to second calculate and go down to 7, the integral of f of x dx, lower limit of -4, upper limit of 4, and there it's going to give me the exact area, and that's very fun to watch, of course, of 85.3 repeating. So, you know, I mean, I got a pretty good approximation here with the 84. This one probably would be even closer. But you can see I underestimated a bunch of places, but then overestimated in about the same way. So it turns out to be a pretty good approximation. So this last page is sort of a summarization, but sketch each of the following area approximations and complete the formulas. Left-hand approximation with 4 subintervals. So that would be 1, 2, 3, 4 subintervals. Left hand is going to start here and not use the last one. So that would be a minus b over 4, because that's the width, right, of each one. And then f of a plus f of x sub 1 plus f of x sub 2 plus f of x sub 3. That would be my left-hand approximation there. Right hand with 4. So right hand would be that, 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 and that. And it would be, again, a minus b over 4. f of x sub 1, we're starting on the right, x sub 2, x sub 3, and b. Midpoint with 4. So midpoint, we're using this now. Midpoint is kind of a pain, but it's not a bad approximation necessarily. Not the same as trapezoidal, right? We're still getting rectangles. And so a minus b over 4 again, and this is going to be the average x value that we're plugging into the function. So this averages the x values, this averages the y values. So we're going to do a plus x sub 1 divided by 2, right, and plug that into the function, then x sub 1 plus x sub 2, then x sub 2 plus x sub 3, then x sub 3 plus x sub 4. So we're averaging the x values and then plugging them into the function. And now 4 subintervals for trapezoidal. Trapezoidal looks like this. Probably the best approximation. And this is also, by the way, equal to the left hand and the right hand divided by 2. So this is different because now we're averaging the y values. Here we were averaging the x values. Only the same if it's linear, I think. So just bear that in mind. So still a minus b over 4 is our width. Then we're going to do f of a and f of x sub 1, and then average those to get a trapezoid, then f of x sub 1 and f of x sub 2, and average those, f of x sub 2 and f of x sub 3, and average those, f of x sub 3 and f of x sub 4, and average those. I realize I've been calling x sub 4 this entire time, so we could just let x sub 4 equal b, right? Because we called it b on our graph. Okay, so that would be your trapezoidal. Not that important to like think about these formulas. Really, when you're doing Riemann sums, you should just be sort of thinking about it and plugging things in, not trying to memorize formulas. Just so long as you know what a trapezoid is, you know what the midpoint is on the left and the right hand, then you should be good to go. Okay?